Hey guys, it's Eddie. Today I want to shoot a quick little video and talk a little bit about insulation. When it comes time to cool the house, most people really don't understand exactly how an air conditioner works. Air conditioners, they don't really cool a house, they maintain the temperature. So when you're sizing an air conditioner for your house, there's a lot of things that go into making sure that you get the right unit for your home. One thing is you have to do a heat load calculation. Now what a heat load calculation does is it looks at your house and it determines how much heat is coming in. It's coming in through your windows, it's coming in through your doors, it's coming in through little cracks and holes that you've got all over the place. They frame up houses, they're not framed perfectly, so there's always gaps, and there's always little problems where heat can come in. Alright, when we're doing a heat load calculation, what we're trying to determine is how much heat's coming in, and they convert that to BTUs. Alright, so if you've got, we'll just say 1,500 square foot house, and you've got 30,000 BTUs of heat coming in per hour, we need to put an air conditioner in that's going to offset that. So we want to go back with the 30,000 BTU air conditioner. Alright, so really what it's doing is it's kind of offsetting heat that's coming into your house. Now, some of the things that can slow down the heat from getting into your house. Alright, so heat enters your house one of three ways basically. The three ways that heat travels are radiant, convection, and conduction. Alright. Conduction is if you're holding a piece of pipe this long, alright, you get your hand on this end and I take a torch and I light this end, the heat travels through the material, so it's not going to take long when I hit that end with that torch. You're still going to be cold here. It's not going to take long before it becomes hot. Alright, so it kind of travels through the object that you're holding or whatever the case may be. Alright, that's conduction. Now convection is convection ovens. You've got your heat that comes on, you've got a fan in it that blows the heat around. So that air movement, basically that's convection. Alright, then you have radiant heat. That's the heat you feel hitting you off from the sun. So if you're standing outside and you're on a hot day, just the heat that you feel, that's radiant heat, that's coming from the sun. Alright, conduction heat we control with insulation in the walls. Alright, there's different thickness of insulation. Your walls have a certain thickness, your ceilings have a certain thickness, and your floors have a certain thickness. Alright, in my area I need R49 in my attic. Alright, I'm supposed to have R18 in the walls and R25 in the floors. But on a 2x4 studded wall, you can only get about R15. It's 3.5 inches thick. And that's, your joists are made out of 2x4s. So if you actually measure the 2x4 joist itself is 3.5 inches, that's about as much as I can get in there. You can't squish insulation. Insulation, basically all it is a certain thickness of fiberglass. They don't mash it together. It's real porous, basically. There's a lot of air in between. So it's like 90%, not 90% air, but it's mostly air. So as the heat attaches itself to that fiber, it's got to make its way through all these little air pockets. It just it slows the heat down from coming in through the wall. So it basically resists the heat from coming through the wall. The thicker the insulation, the longer it's going to take. Alright, I'm trying to explain this without getting way too technical. But that's basically how insulation works. Alright, in the ceiling you should have about 14 inches of blown cellulose. Alright, that's going to get you about an R49. In your walls, If you have a 2x4 wall, it's going to get you about an R15. If you have a 2x6 wall, it'll get you about an R19. Alright, then your floor, they're usually 2x8 choices, and that's going to get you about an R25. Alright, if you get up in your attic, you can figure out your R value. You measure how much you have up there, and for every inch, that's a 3.5 R value on cellulose. 2.5 R value per inch on fiberglass. So if you have 6 inches of fiberglass, multiply that by 2.5, and that gives you your R value. Alright guys, sorry about that. I ran out of memory space. I had to clear up some hard drive there. Alright, so R value is going to determine how much time it's going to take the insulation to come through the wall or ceiling or whatever the case may be. A good way to look at it, it's not exactly accurate, but a good way to look at it, if you have an R49 in your attic, alright, look at it as it's going to take 49 hours for that heat to travel through that. Alright, just get you to think about how the different thicknesses work. If you've got R19 in the walls, look at it as it's going to take it 19 hours to come through the wall. Alright, so that's basically how it works in a nutshell. Alright, R value insulation is not even the biggest deal anyways. The biggest deal is going to be air infiltration. Alright, insulation is good and all, but it does not stop airflow. So if you have holes in the outside wall and the inside walls, that air is going to blow right through that insulation, and it's not going to do anything for you. Alright, it's really important to go around and seal up around all your windows, seal up around your doors, weather stripping. If you can find somebody in your area to do home energy audits where they can do blower door tests, you can find out exactly how much air you have coming into the house. I've been on some of these tests. I've seen some houses that have an equivalent to like a 6-inch hole punched through the wall. Alright, and I've seen houses that have like a 30-inch hole punched through a wall. Alright, you don't want a 30-inch hole on the side of your house. I mean, you're sucking in all kinds of heat. So a lot of times the utility companies, you can call your utility companies and see if they offer blower door tests. I know they do here in Louisville. You want to stop the air from the heat from blowing into your house. Alright, as your house gets older, everything starts to settle. You just develop these leaks, and it's very simple to either go in with silicone, or you can have that spray foam sprayed and it seals up them leaks. It's air sealing. Alright, so the number one thing, if you've got a house that's uncomfortable, there's a few things that I've looked at, because if I go to a house, this is one of the big complaints that we get right now. It's 100 degrees outside and my house is just not comfortable. I checked the air conditioner, it's working perfectly. It's working like a dog. It's 100 degrees outside. But your house should still be mid-70s, whatever you want to keep it. Now I had one guy that was 105 degrees outside and he wanted 69. I think that's kind of stretching it. He told me a month ago that the air conditioner, he would leave to go to work and he would kick it up 4 degrees and he would turn it back down when he got home, and it would cool it 3 degrees in 20 minutes when it was 105 degrees outside. Now I had to doubt that one a little bit, but when I go to these houses, a few things that I look at when I ask about insulation, obviously I've got tools to measure insulation, and I'm going to do all kinds of videos to show you how to do this stuff. Alright. But I got tools where I can measure insulation R values. Alright. I've got tools where I can measure infiltration. Alright, so I know how much air is leaking in, I know how quick air is coming through the walls. That's the biggest problem of a house not cooling. Alright, is that you've got too much heat coming in, and your air conditioner over time just can't keep up with it anymore. Like I said, throughout the years your house settles, or whatever the case may be, whatever change you've made to the house, put in new windows, maybe they didn't seal them up. There's a lot of different things really. I can tell you when I bought my house, it was in 2005. When I moved in here, my house is 1,900 square foot maybe, I don't remember now. I think it's right around 1,900 square foot. When I moved in, it had a 4-ton air conditioner in here. Alright, and it had 120,000 90% efficient furnace in here. Alright, my house would not cool below 82 degrees. Would not do it. In 2005 here, we had over 100 90+ degree days. Alright, so I moved in here in August. Alright, so the first thing I did was replace my air conditioner. I did a heat load. It called for a 2-ton air conditioner. I went with the 3-ton 2-speed air conditioner. Because when it was 100 degrees outside, 105 degrees, we get that every once in a while. I want to make sure I've got the cooling power to do that. My ductwork size for it, everything's fine. So I went ahead and went with the 3-ton. We'll talk about that later. That's another video. Cooled it to maybe 79 degrees, 80 degrees. Cooled it about 2 or 3 degrees more. This is Carrier's 2-stage Infinity Series air conditioner. It's their top line. Alright, it didn't matter. Okay, and I put the variable speed blower and everything in. I put the 2-stage 90%, 60,000 BTU variable speed furnace in. Didn't matter. Didn't matter at all. Alright. So a week later, I let it run for a little bit. I know my first bill that I got was over $400. I mean, I almost had a heart attack. Alright. Put this new system in. My second bill, same temperatures, it was 90 degree days. It dropped it down to like 320 or something like that. Saved me about $80. Somewhere around in that area, I don't remember, that's been a little while back. Alright, but I'll tell you, I was pretty upset that my house wasn't cooling. Alright, so I got searching around. It's like, what the heck could be causing this? Why am I mean, it should be fine. Alright, so I got digging around. I got up in my attic. Now, it was like 92 degrees out that day. And my God, it must have been 150 degrees up in my attic. It was really, really hot. I was like, you know, your attic should never be, it should be no more than 20 degrees hotter than it is outside. So if it was 90 degrees outside, 110 degrees should have been it. No more than that. Alright. It was about 155 degrees actually. And it was really hot up there. Alright, so just a ranch house that I've got. That had 4 of the little vent caps on the back. Alright, so whoever put this roof on, whoever built the house, there wasn't enough vents. Alright. So I measured the square footage, I went to Lowe's. I'm not a roofer, I don't know anything about ventilation on the attics, and that's just not what I do. I don't know anything about it. But I got reading on the box for them little caps. Alright, for my size house I needed 12 of them things. Alright, I had 4. Alright, I could have went with 4 of the turbines, the little whirlybird ones that spin. Or I could have put a power fan up there. Now, I chose to go with the power fan. Now, whatever method that you go with, what goes out must be replaced by fresh air coming in. So you have vents all the way around the soffits, right underneath the gutters. You got vents, intakes, and you've got your exhaust. So I got my fan up there, cranked it on, got feeling around, and just didn't feel, there wasn't a whole lot of heat coming out. Now I've got the vinyl siding soffits, and every once in a while there's one in perforation, one with the holes in it. Alright, I took a little coat hanger and I stuck it through the hole, it would. I did that all the way around the house. None of them had holes cut. So I had a buddy of mine come over and we walked all the way around the house. We ended up cutting like 16 holes all the way around my house. Alright, wasn't a single one of them cut. The very next day my house cooled to 72 degrees. No problem. Not a problem, not a problem. Alright. I think since then my highest bill has been about 160, 170 bucks. I think 180 bucks, somewhere right in there. It's been under 200 bucks. I haven't had a bill over 200 bucks. Alright, so that just goes to show that there's so much more to making your house comfortable than just your heating and air conditioning. Alright, you have to look at your house as a system and you have to determine what the problems may be. Alright, there are a lot of quick, easy tests that you can do. Find somebody that does the infiltration test, the blower door test. Alright, you can take off the switch covers on the outside walls if you've got registers on your walls. Take your registers off and stick a coat hanger up in there and see if you feel any insulation. If you take your electrical switches off, please be careful. There's 110 volts in there. But you don't need to get around that. Just kind of stick it on the outside of that box and just kind of shine a light up in there or whatever and look and see if you got any insulation up there. But the best thing to do if you've got registers in your walls, just pull them things off, pull that boot down a little bit and look up in there and see if you can see any insulation. There's a tool that I've got. I'm going to show you how you can measure it digitally if you want to. Alright, I'm getting ready to show you that in a second. But, you know, infiltration, insulation, and making sure your attic's vented. I went to Walmart. I got me a little $15 wireless thermostat, or thermometer I mean. There's a little outdoor sensor that goes outside and you've got your indoor readout. That mounts right above my thermostat now. My outdoor sensor is up in my attic. Alright, so now I keep that up there just in case my fan were to go out. Alright, so I would be on top of it now. It never gets no more than 20 degrees hotter out than it is outside now. It maintains a perfect 20 degrees. Okay, my house stays comfortable and my bills, I cut them things 60-70%. So, you know, think about that when you go into these houses when they're complaining that their houses aren't cooling or it's just not comfortable, it's humid, sticky, whatever. Just keep that stuff in mind. Look at insulation. I know I'm just going to keep repeating this. We got to get this stuff right. Insulation, infiltration, and make sure your attics are venting. That'll solve a lot of problems. So let me show you this tool that I've got. We can measure R value and, you know, maybe you'll like it. Alright guys, so to measure R value, I'm using my Testo 435. I know you are saying, my God, it's that daggone 435. You know, this meter, it does a lot. You know, it is an expensive meter, but with everything that this thing is capable of doing, I think every tech needs to have one. We complain a lot about cost of our tools. Do any of you have a mechanic that you know that's a good friend? Alright. You know, auto mechanics, they buy their own tools. Alright, if you're a good auto mechanic, most of these guys are buying from Mac, Snap-on, whoever. I mean, these are like high dollar tools. I just had a guy put some plugs in my truck about a week ago. Alright, he just bought him a Snap-on tool chest, just a big toolbox. Alright, he asked me how much I thought it was, and it's like, I don't know, $1,000 bucks. I don't know anything about them. $25,000 he paid for his tool cabinet, and it's just like a little roll. It was probably 8 foot long, maybe 3 foot, 4 foot wide. I don't know. I mean, it's a pretty good size tool cabinet. $25,000, and that's no tools. You know, they're paying $40,000, $50,000 in tools. All right, $1,100 bucks. Come on, guys. I mean, you can buy the meter for $900,000, somewhere around in there, then buy all your accessories a little bit at a time. These things are going to save you time and time and time again. I can't even begin to tell you how much money I've made with this thing. Alright, you know, I'm not going to talk about this in video, but if you want to talk about this, shoot me an email, I'll give you my phone number. I'll be glad to talk to you on the phone about this. Alright, but this thing has, you're going to make your money back really fast. I promise you, you will make your money back. Alright, you have to have the tools, you have to test. If you're not testing, you're guessing. Let's get this stuff done right. So let's get back, I'm rambling on. Let's get back to measuring R values. So you need this, you need one wireless probe, and they have this other attachments for measuring U value. Alright, so basically what it is, for what I understand, there's a thermometer in here, got a thermometer here, and there's 3 wires here that's measuring temperatures. Alright, so what we're going to do, we're going to stick this with some putty to the inside wall. This is going to go on the outside wall. Then this is going to measure the difference in between. It gives you an R value. It measures the resistance and the heat transfer. So let's get this hooked up and I'll show you. Alright guys, there's the temperature probe outside. Alright guys, here's the probes on the wall. Alright, right now it is 85 degrees outside, and the top number there is my U value is 0.06. Alright, so let me show you how to convert that to R value. Alright, you get your calculator. To convert it to R value, it's 1 divided by your U value, which in my case is 0.06. So that tells me I've got an R value of 16 in my wall. And this is figuring the insulation, the brick, the whole wall system is 0.16. Alright, so that's how you can figure out the R value of your wall. You can use it to measure your walls, your windows, your ceilings, your floors. You know, you can determine how much insulation that you've got. You know, so just kind of keep that in the back of your mind when you're in the house with the customers complaining about a house not being comfortable. Just let them know that air conditioning is just basically 25% of what it takes to cool the house, the air conditioning system. There's another 75% that they're not even thinking about. Insulation, infiltration, and everything else that's involved. Alright, so hope this helps one of you. Like I said, if you've got any questions about the 435 or any of the Testo tools, you can give me a shout. You shoot me an inbox and I'll shoot you my phone number and we can call and talk about it. I think it's a tool that's well worth having. You know, it'll make your money back. I can almost guarantee you that if you use it properly and use it for everything that it's worth. So good luck guys, and again thanks for watching the videos, and we'll see you on the next one.